Find all functions g such that g prime of x equals this function. So what we want to do, we've got this function and we want to find its antiderivative. I'm first going to re-express this function in a little different form so it'll be easier to find the antiderivative. We know that we can find the antiderivative of each term because when we differentiate, we know that the derivative of sum is the sum of the derivatives of each piece. So we could handle this 4 sine x by itself. But this other piece is quite complicated with this quotient, so I'm going to rewrite it by putting this x under each of these terms. And if I apply that to the 2x to the 5th, it becomes 2x to the 4th. And then we have minus, and if I apply this, think of this x, square root of x as x to the 1/2, and then we have over x. So that's going to be x to the negative 1/2. As we combine those exponents. And that's going to be the form we want this in because we can figure out an antiderivative of each term and we can do the power rule in reverse for these two guys, and so we want them written as x's to some power. Now we are ready to figure out what function this was the derivative of. Looking at the first term, the derivative of some function that gives me a sine, well, I know that would be a cosine, but when I take the derivative of cosine it should be negative sine, and there's no negative there, so I'm going to need a negative, and then the 4 is just a constant out in front. Very quick check then, the derivative of negative 4 cosine x is negative 4 sine x. The two negatives cancel, and there we go. Next term, I'm going to need x to the 1 higher power, so that would be an x to the 5th. I don't see that out in front, so 2 is a constant out in front. I need to also multiply by the reciprocal of that power, so that when I take a derivative here and the power comes out in front, the 5's will cancel, leave me the 2, then decrease the power by 1, and I do get that term. Last one then, I'm going to have an x to the 1 higher power. 1 higher power of a negative 1/2 would be a positive 1/2. So this minus sign is still going to be here. When I bring the power out in front, I need a reciprocal of 1/2, which is 2, to cancel with that. So you can see as I brought that out in front, the 2's would cancel. When I decrease the power by 1, I would end up with that. And of course we need our arbitrary constant on the end because there could have been anything there that when we took the derivative of a constant it would have disappeared because it would have been 0.